Welcome back! So far in this boot camp, you've learned Python fundamentals, how to work with data using pandas, how to clean datasets, and how to analyze and visualize data. Now it's time to explore one of the most important foundations of data science: statistics. Many beginners feel nervous when they hear the word statistics. They imagine complicated formulas and difficult calculations. But here's the good news. In data science, statistics isn't about memorizing formulas. It's about understanding data logically so you can make better decisions. Let's dive in. Why statistics matters. Imagine you're still helping Matthew manage his business in Dubai. Matthew starts asking questions like, what is the average customer spending? Are sales increasing over time? Is this customer's behavior normal? Can I trust this data before making a business decision? These are questions that statistics helps answer. Without statistics, we're simply guessing. With statistics, we can summarize information, identify patterns, measure uncertainty, and make decisions backed by data. Statistics transforms raw numbers into meaningful insights. Let's begin with descriptive statistics. Descriptive statistics means summarizing and understanding a dataset. Instead of manually looking through hundreds or thousands of rows, we calculate a few statistical values that quickly describe the data. We'll continue using our customer purchase dataset from Matthew's business. Each customer has a purchase amount, and our goal is to understand spending behavior. The first measure is the mean, also known as the average. To calculate it, we add all purchase amounts together and divide by the total number of customers. Using pandas, this is as simple as calling the mean function. In our dataset, the average customer spending is 1,660. This gives Matthew a quick overview of how much customers typically spend. Businesses use averages everywhere. Average sales, average salaries, average monthly revenue, average customer spending. It's one of the most commonly used statistical measures. Next comes the median. The median is the middle value after sorting the data from smallest to largest. Why is this important? Because averages can sometimes be misleading. Imagine one customer spends $30,000, while everyone else spends around $1,000. That one unusually large purchase increases the average significantly. The median isn't affected as much by these extreme values. In our example, the median purchase amount is $1,500. This often represents the typical customer more accurately than the average. Mode, most common value. Now let's talk about the mode. The mode is the value that appears most frequently. In our small dataset, every purchase amount appears only once. That's why Pandas returns every value as a mode. In a real business scenario, if most customers spend exactly 1,000 dirhams, then the mode would be 1,000. This helps businesses identify the most common customer behavior. Range, understanding variation. The range measures how spread out the data is. It's calculated by subtracting the smallest value from the largest value. In our dataset, the highest purchase is 3,000 and the lowest is 700. The range is 2,300. This tells Matthew that customer spending varies quite a bit. Another important measure is standard deviation. Don't let the name scare you. It simply tells us how much the values differ from one another. If every customer spends nearly the same amount, the standard deviation is low. If some customers spend very little while others spend a lot, the standard deviation becomes higher. Our dataset has a standard deviation of around 968.5. This tells us that customer spending varies noticeably. Understanding variation helps businesses identify consistent patterns and unusual customer behavior. Now let's introduce probability. Probability measures the chance that something will happen. For example, what is the probability that a customer buys again? What is the probability that someone clicks an email campaign? Suppose Matthew has 5 customers, and 2 of them are premium members. The probability of randomly selecting a premium customer is 2 divided by 5, which equals 0.4, or 40%. Probability helps businesses estimate future outcomes and make informed decisions. Distributions and histograms. Statistics isn't only about numbers, it's also about understanding how data is distributed. A distribution shows how values are spread across a dataset. One common way to visualize this is with a histogram. A histogram groups similar values together so we can quickly see where most observations fall. In our customer dataset, most purchase amounts are below $2,500, while only a few customers make larger purchases. This gives Matthew an immediate understanding of customer spending patterns. One special type of distribution is the normal distribution. It has the famous bell-shaped curve. Many real-world datasets follow this pattern. Most values are close to the average, while very high and very low values are much less common. Examples include human heights, exam scores, and delivery times. Many machine learning algorithms perform better when the data follows a normal distribution, making this concept extremely important. Finally, let's understand hypothesis testing. Businesses constantly make assumptions. Matthew believes that offering discounts increases customer spending. But how can we verify that? This is where hypothesis testing comes in. We begin with the null hypothesis, which assumes there is no effect. In this case, it says discounts do not increase spending. Then we have the alternative hypothesis, which suggests that discounts do increase spending. By comparing customer spending before and after discounts, we can use statistics to determine whether the observed difference is likely real or simply happened by chance. This process is widely used in marketing campaigns, A/B testing, product improvements, and customer behavior analysis. In our final mini-project, we calculate the mean, median, range, and standard deviation using just a few lines of Python code. These calculations allowed Matthew to better understand customer spending without manually analyzing every record. This demonstrates the true power of statistics. It helps us summarize data, discover patterns, and make confident, data-driven decisions. Congratulations! You've now learned the core statistical concepts every data scientist should know. You understand descriptive statistics, mean, median, mode, range, standard deviation, probability, distributions, normal distribution, and hypothesis testing. These concepts form the foundation of data science, artificial intelligence, machine learning, and business analytics. If you understand these ideas, you're well prepared to move into the exciting world of machine learning. Now it's time to test your knowledge with the Lesson 6 quiz.